Hello students, in this video we will study about the basics of protection of power system, the relays which we used, and in the previous chapters which we have studied in the previous presentations and videos, we have discussed some basic concepts and now we will move towards advanced relay schemes. Now relay will be detailed as follows. These are the basic diagrams of the relays practically used in real-time network. Now this is basis the syllabus. It consists of electromagnetic relays, means those relays which works on the magnetic phenomena, over current relays to detect over current value, directional relays to identify the fault in a particularized direction, because as per the requirement of the system, if we have a ring system, or if we have generator, if we want to take seriousness over a generator, since because generator is an costly equipment, and if we want to save the generator, sorry, if we want to give more priority to the generator, then we can use directional relay, so that if any kind, in any case, if there is any reverse fault current that may entering into the generator, then by detecting the direction of the approaching fault current, the directional relay will act upon and will directly work for its isolation and for the safety of the generator purpose. That why for such condition where directional property is judged, we use directional overcurrent relays. Similarly, non-directional relays, which can be used for both directional and non direct, having both directional properties. Similarly, distance relays is also there. This type of relays actually works on identifying the parameters. Since we have used for it these types of relay for a particular area, means for that particular area, parameters are already fed in the network. They are already set in the brain or in the mind of that relay, and particularly when the CTs and PT provide input through these relays, then it is being compared to the set or threshold value which we have set. If it is on marginal level, then it is being allowed, but if it is crossing the marginal level, then they are approaching towards setting the operating limits of the relay, and after then onwards our relay will work and it will try to action the circuit breaker. Similarly, negative sequence relay is an application part. Differential relay is a great big scheme for identifying faults in those utilities or those equipments where the input and output are is available at the utility end. Means we can use differential relay to all those areas where input and output points of that assemblies are available at the utility side. For example, in transformer, bus bar, in generator, in all these units, the input and output points are available at one end. While in case of transmission line, the distance between the input and output end may be more than 20 kilometer, 50 kilometer, which is very high. So differential relay is generally used in this type of condition, particularly as a constraint under frequency relay and introduction of static relays. That in how many classifications the relays have been classified from time to time as the generation changes. Relay overview is detailed here. What are relays? Relays are electrical switches that open or close another circuit under certain conditions. It is basic diagram of relay working. Now as we see, here is the armature. It is the actuating quantity. These are the contacts which generally initiate the uh, message, conveying message. This is the DC volt battery which provides the value to the armature current, and it is the basic of the relay working, that how relay works. When it closes the switch, then certain type of current will flow in that particular coil, and that will attract this armature and it will move towards contact point. It is the basic working of a relay. Relay purpose that to isolate the controlling circuit from controlled circuit, to control high voltage system with low voltage, to control high current system with low current, and logic functions. It is the basic diagram how it works. When this particular codes attracted area armature attracted towards this coil which having magnetic properties, when battery is passing, when battery circuit is connected during a fault condition, then our bulb will blow on. Now what are types of the relays? Then electromagnetic attraction type of relays are there, having attracted armature type construction, solenoid type relay construction, and balanced beam type relay construction. These are different types of arrangement, because minor electronic types equipments and some attraction type coils are being designed, which is generally we use to study in physics concepts. Induction relay oblique electromagnetic induction relay. Induction type overcurrent relay, it is a non-directional relay. Induction cup relay, it is a directional relay. Now we will see attracted armature type relay construction. It is having a spring here. It is a unit which is being tied to our setup to trip circuit. Voltage or current values entering here. So these have a coil or electromagnetic energized by a coil. The coil is energized by operating quantity like V or I. Under normal conditions, the coil cannot attract the plunger due to spring force. Under fault condition, the fault current increases, so armature plunger gets attracted to close the contacts. Now attracted armature type relays basic operating principle. The electromagnetic force developed on a moving element is proportional to square of the flux and air gap. If saturation is neglected, then force will be proportional to the I square. F equals to K1 I2 square minus K2. These are the constants. F is the net force, K1 K2 constant, restraining force including friction. I is the current in the relay coil. When relay is on the verge of operation, K1 I square equals to K2, or I equals to under root of K2 upon K1. That will be a constant value. What are the basic advantages? Relay responses to both AC and DC, means torque is directly proportional to I square. So it is a good quality that it is not biased for the particular value of a current, that it is a AC type or a DC type. It responses to both similarly. Light moving parts are there, small length of travel of armature or plunger in air gap, therefore relays are fast in operation. These relays are instantaneous, but operating time varies with current. It depends on characteristics. We can observe through them. The operating time and the resetting time can be adjusted by adjusting the air gap. So relays can be made slow operating relay. Attracted armature type relay applications for overcurrent protection, differential protection, auxiliary relays, definite time lag overcurrent, and earth fault protection scheme. As we see in the diagram, as the operating time increases, fault current value increases, and as that type of relay works. Solenoid type relay. Now it consists of a solenoid and movable iron plunger arranged as shown. Under normal operating conditions, the current through the relay coil C is such that it holds the plunger by gravity or spring in the position shown, and this is in the diagram. However, on the occurrence of a fault, the current through the relay coil becomes more than the pickup value, causing the plunger to be attracted to the solenoid. The upward movement of the plunger closes the trip circuit, thus opening of the circuit breaker and disconnecting the faulty circuit. Yeah, this is a solenoid. It is the message sending to trip circuit. It is the iron plunger. Now third, balance beam type relay. It consists of an iron armature fastened to a balance beam. Under normal operating conditions, the current through the relay coil is such that the beam is held in the horizontal position by the spring. When a fault occurs, the current through the relay coil becomes greater than the pickup value and the beam is attracted to close the trip circuit. This causes the opening of circuit breaker to isolate the faulty circuit. Now balanced beam type relay. Iron armature is used. This is that goes to the trip circuit. It is a fixed coil type arrangement and this is the spring. Now induction cup structure is detailed hereby. It mostly closely resembles an induction motor except that the rotor iron is stationary, only the rotor conduction portion being free to rotate. The moving element is a hollow cylinder rotor which turns on its axis. The rotating field is produced by two pairs of coil wound on four poles as shown. The rotating field induces current in the cup to provide the necessary drive. Here it is it sends message to the trip circuit. It is the stationary core, it is the rotor, S1, S2 are the two input providing values from CTs and PTs. Now induction cup structure can be detailed. If phi1 and phi2 represent the flux produced by the respective pairs of poles, then torque produced is proportional to phi1 phi2 sin alpha, where alpha is the phase difference between the two fluxes, a control spring and the backstop for closing of the contacts carried on an arm are attached to the spindle of the cup to prevent the continuous rotation. Induction cup structures are more efficient torque producers than either the shaded pole or the watt or meter structures. Therefore, this type of relay has very high speed and may have any operating time less than zero point 0.1 second. Induction type overcurrent relay, non-directional relay. Induction type overcurrent relay, non-directional relay. This type of relay works on the induction principle and initiates corrective measure when current in the circuit exceeds the predetermined value. The actuating source is a current in the circuit supplied to the relay from a current transformer. These relays are used in AC circuits only and can operate for fault current flow in the either direction. It is the basic diagram of induction type or current relay. This is the movable unit. It is to the trip circuit. After receiving message from this circuit, it tries to operate. Here it will receives value from CT. Construction details. It consists of a metallic disc which is free to rotate in between the poles of two electromagnet. The upper electromagnet has a primary and a secondary CT and the line to be protected and is tapped at intervals. The tapping are connected to a plug setting bridge by which the number of active turns on the relay operating coil can be varied. Similarly, the secondary winding is energized by induction from primary and it is connected in series with the winding on the lower magnet. The controlling torque is provided by spiral spinning. The spindle of the disc carries a moving contact which bridges two fixed contacts. When the disc rotates through preset angle, the angle can be adjusted to any value between 0 and 360 degree. By adjusting this angle, the travel of the moving contact can be adjusted. Lastly, we will study the operation. The driving torque on the aluminum disc is set up due to the induction principle. This torque is opposed by the restraining torque provided by the spring. Under normal operating condition, restraining torque is greater than the driving torque produced by the relay coil current. Therefore, the aluminum disc remains stationary. If the current in the protected circuit exceeds the preset value, the driving torque becomes greater than the restraining torque. Consequently, the disc rotates and the moving contact bridges the fixed contact when the disc has rotated through a preset angle. The trip circuit operates the circuit breaker which isolates the faulty section. So this is all over in this video. We will discuss some basic more relays in the next video.